Great. Hi guys, welcome back to the Mathly, your exclusive platform for your SAT Maths preparation. Great. Now, continuing from the last class, today we are going to start with session 2, the next session. Basically, what we'll be learning something about the conditions of solubility. Is that okay? Conditions of solubility, right? Like what are the conditions? Let's suppose if the two pair of equations are given, can we get the solution whether the lines are parallel, intersecting, or whether the lines are coincident? You don't need to go by the wordings or proper. You just need to understand the reason, the logic behind it, right? So let's get started. Now, if you guys can remember, in the last class we discussed how we can plot. Let's suppose if I write the equation 2x plus 3y is equals to 6, and we discussed how we can plot this on a graph paper. Plot this on, sometimes I miss some words. That's okay. Plot this line on graph paper, isn't it? That's what we have discussed. Now, in this class, in this session, the session number 2, we are going to discuss what if we are given a pair of linear equation, pair of linear equation pair of linear equations. What if we are given a pair of linear equations? Now let's take an example. If I take an example, let's suppose we are given 2x plus 3y is equals to 6. Now we are given 2x minus 3y is equals to 6. Let's suppose we are given a two pair of linear equations. Now let's understand how we can solve them. Very famous method available, that is known as elimination method. You guys must have done it. If you have not done it, that's really very easy. What you need to do is what you have to eliminate one variable. You have to eliminate one variable. Now how we can do it? Let's see. We have 2x plus 3y is equals to 6. We have to 2x minus 3y is equals to 6. This is our first equation. This is our second equation. We are given. Now the thing comes in, what we need to do, we have to multiply, divide the first equation or second equation so as to make one variable same. Now can you see over here, we have 2x and 2x, they are same, and 3y and or minus 3y the same, right? Now if you just see very clear, if I add these two equations, if I just add them, what will happen? This will come out to be what? 4x. This will be what? 3y minus 3y. This will be equals to 2. Can you see now? They will cancel out and we can eliminate the variable y and we can get the value for x. This method is known as eliminating the one variable. This method is known as elimination method, right? Now, once we have got the value of one variable, we can find out the value of another variable. Like just substitute it any of the equation. Now, let's see. Let's substitute in the first equation, right? So we'll get 2x, we have x values 2 into 3 plus 3y is equals to 6. So 6 plus 3y is equals to 6. So 3y is equals to 0. Y will be equals to 0. This is the solution of pair of linear equations. So this is elimination method, the very famous method. I hope everyone must have done it. Now the real problem comes in. Now let's suppose if I, what happens is, let's suppose what happens is, whenever we I'll write the equation once again. Let's suppose we are given this equation and we are given this equation. Now when we try to solve the question, do you think whenever we are given a pair of linear equation, we always have a solution? We don't always have a solution, right? Sometimes what happens is, what we think that, okay, now we are given a pair of linear equation, let's solve them by elimination method, and we are not able to solve it. The reason behind it, what? Because we don't know whether the lines are intersecting, isn't it? Whether the lines are we don't know. We don't know. We don't know whether the lines are intersecting, whether the lines are parallel lines, isn't it? Or whether the lines are coincident. These are the three simple scenarios that can happen. We don't know until unless we solve it. But we don't want, in SAT exam, we don't want to waste that much time. Let's suppose you are given a pair of linear equations. First you try to solve them, then you come to the conclusion, okay, I'm not able to solve it. So the lines do not have a solution. So this means what? We should have some method. We should have some test where we can test these pair of linear equations whether we have a solution or not. That's what we are going to discuss in the class today, right? That is known as condition of solvability. That's okay. We'll discuss a lot of example how that situation can be helpful. Let's discuss it, right? Now, let me clear the board. Now, you know what? If you think it very clearly, we have three possible scenarios for the pair of linear equation. One can be what the lines can be intersecting, like this way. The lines can be parallel, or the lines can be coincident, like this way. I'll try to draw a different color. The lines can be coincident. Now let's suppose how we can come to the conclusion. When the lines are intersecting, do we agree the slopes are not equal? Let's suppose if I write like this way, this equation is what y. I can write this as m1x plus c1. Let's say this equation is what? This line is what? Y is equals to what? m2x plus c2. Now in intersecting lines, the slopes are never equal, right? Now when we have a parallel lines, in parallel lines, the slopes are always equal and the intercepts are never equal, isn't it? But when we come to the coincident line, now in this one, you can, you know what? In this one, the slopes are equal and the y-intercepts are also equal, isn't it? Now, let's see how we can use this situation, how we can use this scenario to get to the conclusion, right? Now, let's see how we can do it. Now, before I start with it, before I move on with it, let's, you know what, discuss one very important part as for your SAT. Very important part, right? Now, what will happen in SAT? Most of the time, most of the time, the equations will be given in general form. Now, let's discuss the general form. The general form is this: ax plus by is equals to c. That's your general form. And you know what? By giving a general form, they'll ask you, and they will ask, they'll ask you to find we can say the slope, right? Now what you guys will do, you will try to convert this into slope intercept form, isn't it? You'll try to convert this into a slope intercept form. You can go like this way: by is equals to what? Minus ax plus c. You can divide by b. You'll get y is equals to what? Minus a by bx plus c by b. This is how you can get to the slope intercept form, and then you can say further that this is the slope, right? This is a slope. But in your SAT, you don't have that much time, isn't it? You don't have that much time. This is the biggest problem. So instead of that, let's suppose we are given a general equation ax plus by is equals to c. Instead of that, let's suppose we are given a general equation, general form of an equation. The slope will be negative of a coefficient of x upon a coefficient of y. Simple. Whenever the equation is given in a general form, you can find out the slope by using this formula. Simple as that, right? Now let's discuss some of the examples. Let's suppose we are given 3x plus 4y is equals to 6. We want to find out the slope. How we can find out the slope? Negative of a coefficient of x, that is what, 3, upon a coefficient of y, that is what, 4. That's your answer. Simple as a concept. Let's discuss one more example. Let's suppose we have 5x is equals to what? 4y plus 3. So we have 5x minus 4y is equals to 3. So the slope is going to be what? Negative of the coefficient of x upon the coefficient of y. This and this will cancel out. The slope will come out to be 5 by 4. I hope the things are clear. How we can find out the slope when the equations are given a general format. Great. Now let's come back to the situation. The same thing we were discussing. Let's suppose we have intersecting lines, we have parallel lines, and we have a coincident lines. We have coincident lines. Great. Now, In this one, we know that the slopes are not equal. Simple. In this one, we know that slopes are equal, but y-intercepts are not equal. Y-intercept not equal. In this one. And for this one, we'll discuss it later. Now what I'll do is what? I'll write the equation in a general form. Let's say this is a1x plus b1y is equals to c1. Let's say this is a2x plus b2y is equals to c2. Now, when the slopes are not equal, now I can find out the m1 directly by using a negative of coefficient of x, that is a1 upon coefficient of y, that is what b1. Same way, I can say m2 will be what? Negative of a2 upon b2. Now we know that the lines are intersecting, the slopes are not equal. So I can say negative of a1 upon b1 will not be equals to what? Negative of a2 by b2. This and this will cancel out. I can rearrange it. I can say a1 by a2 is not equals to what? b1 by b2. That is the test. Means what? Whenever we are given a pair of linear equation, if I know that a1 by a2 is not equals to b1 by b2, first you need to convert them into a general form. If a1 by a2 is not equals to b1 by b2, I can immediately say that the lines are intersecting. Things are clear? Same way, we need to find out the situation for the parallel lines. When the lines are parallel. Now, the slopes are equal. I can say negative of a1 upon b1 should be equals to what? Negative of a2 by b2. Now, this will be what? a1 by a2 should be equals to what? b1 by b2. Just rearrange it. This and this will cancel out. This will go into this direction, right? And this will go into the upward direction. Now, one more condition is given over here. Y-intercepts are not equal. One more condition is given here that the y-intercepts are not equal. Now, let's see how we need to do it. Let's see how. I'll just erase this part. We'll discuss it later. Now, let me write the general equations over here. Let's say this is a1x plus b1y is equals to c1. Let's say this is what? I can say a2x plus b2y is equals to c2. Now, how do we find y-intercept? Put x is equals to 0. You remember from the first class I told you, if you want to find out the y-intercept, put x is equals to 0. Simple. Now, if I put x is equals to 0, this part will become 0. So, I'll get what now? a1 into 0 plus b1y is equals to c1. So, this will be what? b1y is equals to c1. So, y will be equals to what? c1 by b1. Right? So, you know what? Same way I can write for the y-intercept for this one also. I can say y will be equals to what? c2 by b2. Now, the y-intercepts are not equal. So, I can clearly say that c1 by b1, I can clearly say that c1 by b1 will not be equals to what? c2 by b2. So, I can say c1 by c2 is not equals to what? b1 by b2. This is the second condition. Now, can we combine these two? How can I combine these two? Because you know what, this one and this one is common. So I can say then a1 by a2 is equals to b1 by b2, but it should not be equals to what? c1 by c2. This is the test condition for the parallel line. If the ratio of a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2, the lines are parallel. Very simple concept, right? Now, let's move on to the last concept, that is what? When the lines are coincident. Now, let me draw it. Let's say this is the first line. By the way, when I say the lines are coincident, means what? They are overlapping. They are overlapping. Overlapping lines, right? Now, let's suppose this is a1x plus b1y is equals to c1. This is what? a2x plus b2y is equals to c2. Now, in this case, what happens is what? The slopes are equal and the y-intercepts are also equal. They are also equal. Right? Now, when I say the slopes are equal, I can say minus a1 by b1 will be equals to what? Minus a2 by b2. This and this will cancel out. I'll say a1 by a2 will be equals to what? b1 by b2. Am I clear? Now, when I say the y-intercept, so y-intercept means what? Y is equals to what? I can say c1 by b1. I can say c1 by b1 will be equals to what? c2 by b2. I can say c1 by c2 will be equals to what? b1 by b2. Now again I can combine these two conditions. b1 by b2 is common. I can say a1 by a2 will be equals to what? B1 by B2 will be equals to what? C1 by C2. This is the test condition for the overlapping lines. I hope the things are clear now. This is a really important concept as per your SAT exams are concerned. We'll discuss some questions. I'll discuss with you like what type of questions are asked. So you know what you need, how you need to apply the concepts, right? Now let's come back to the practice questions now. Let's discuss one example over here. Now I have seen this type of question many times asked in your SAT exam. So let's suppose we are given 2x plus 3 is equals to what? 2x plus 5 we are given, and we need to find out how many solutions are possible. How many solutions how many solutions are possible? Now how we can do it? Now you know what, to solve such question people do is what, they'll try to simplify. Don't try to simplify. First of all, don't simplify it. Don't simplify, right? That's the first thing. Now what you need to do is what, you need to think it's like a slope matrix form. Now you can think like this way: m1x plus c1. Let's say this is what, m2x plus c2. Now compare it. Now if you compare it, can you see m1 is 2, m2 is also 2. So I can proudly say that slopes are equal. Slopes are equal. But c1 is 3 and c2 is what, 5. So c1 is not equals to c2. So this is a condition for what? This is a condition for what? Isn't it? This is a condition for parallel lines, isn't it? And parallel lines have no solution. Parallel lines have no solution. I hope you agree. So I can say that no solution is possible for this. No solution is possible. No solution is possible. I hope the things are clear now. Correct? Now let's discuss one more question over here. Let's discuss one more question. One more question. Great. So let's suppose we are given 2x minus 3y is equals to 6, and we are given 4x minus 6y is equals to 8. We need to find out how many solutions are possible. How many solutions are possible? Now, in such a scenario, you don't need to solve the question. Please, first of all, don't solve it. Don't solve the pair of linear equation. Don't solve the pair of linear equations. Is that okay? Now, what you need to do is what, you need to apply the simple concept. Let's say this is a1x plus b1y is equals to c1. Let's say this is a2x plus b2y is equals to what, c2. What is a1 by a2? That is what, 2 by 4, which is what, 1 by 2. What is b1 by b2? That is minus 3 upon minus 6. This and this will cancel out. The answer is 1 by 2. What is c1 by c2? That is what, 6 by 8. The answer is what, 3 by 4. Now if you see it very clearly, a1 by a2 is equals to b1 by b2, but it is not equals to c1 by c2. This is a condition for a parallel line, isn't it? This is a condition for parallel lines. So I can again proudly say that this is no solution is possible. No solution is possible. I hope the things are clear now, like what kind of questions can be asked, right? Now let's discuss the last concept for the day, that is that format. Now let's suppose first format, second format, and third format. Now the first format says that if ax plus d is equals to cx plus d, we'll have a unique solution. We'll have a unique solution. Please, I'm telling you once again, these type of format many times it is asked in SAT. Is that okay? Now over here the slopes are not equal. Now second thing is what, we have ax plus b is equals to what, ax plus c. The slopes are equal, but the intercepts are not equal, so we'll have no solution possible. No solution possible. Zero solution. So then we have ax plus b is equals to what, ax plus b. In this case, I can say more than two solutions are possible. More than two solutions are possible. Is that okay? Am I clear? Great. So that's it for the day. You don't need to worry about some of the practice questions. will do a lot of practice question. You don't need to worry. We'll have a separate class for the practice question. But my point is, what first focus on your concepts, focus on your understanding. If you have any kind of a doubts or a concern, you can please post on your comment section. We'll take care of your doubts. You don't need to worry. But I would request you to please watch these videos carefully because these are going to be really helpful for your ACT exams. So thank you so much. See you in the next class. Till then, bye. Take care.